Earth Materials and Processes. Hello everyone. Welcome to our subject, Earth and Life Science. Today, we're about to dive into an exciting and essential topic called Earth Materials and Processes. This lesson is important because it helps us understand the very foundation of the world we live in. From the ground beneath our feet to the towering mountains around us. In this lesson, we'll focus on the building blocks of our planet, rocks and minerals. These are the natural materials that make up the Earth's crust. We'll explore how they form, how they look, where they're found. And most interestingly, how they constantly change over time through natural processes. You might think a rock is just a rock, but every rock has a story, a history that tells us about Earth's past, present, and even future. Let's begin with a question. What do you think these places have in common? That's right. Rocks and minerals. They are the foundation of our natural environment and the materials that shape the landscapes we see every day. Let's start with what is rocks and minerals. In Earth and Life Science, rocks and minerals are two of the most important natural materials that make up the solid part of our planet. Although people sometimes use these words interchangeably, they are actually different from each other. Let's carefully define and explain them. A rock is a naturally occurring solid mixture made up of one or more minerals. Mineraloids, mineral-like substances, and sometimes organic materials. A mineral is a naturally occurring, solid, inorganic substance with a definite chemical composition and an orderly arrangement of atoms. In simple words, a mineral is a pure substance found in nature. Think of a rock as a combination or collection of minerals. It doesn't have a specific chemical composition like minerals do, and it can be made of different types of minerals mixed together. Types of rocks. Now, let's talk about the three main types of rocks. 1. Igneous rocks. 2. Sedimentary rocks. 3. Metamorphic rocks. Igneous rocks. The word igneous comes from the Latin word ignis, meaning fire. Because these rocks are formed from cooled and solidified molten rock. Igneous rocks are formed when hot, molten rock material called magma or lava cools down and becomes solid. This cooling process releases heat, making it an exothermic process, a change of phase from liquid to solid state. Generally hard and tough. The texture of igneous rocks depends on how fast the magma cools. 1. Aphanitic or fine-grained. Aphanitic, from the Greek word aphanes, meaning invisible, describes the texture of igneous rocks where the individual mineral crystals are so small that they cannot be seen with the naked eye. This texture occurs when magma or lava cools very quickly, not giving the minerals enough time to form large crystals. Fast cooling happens at or near the Earth's surface during volcanic eruptions or lava flows. Example, basalt. 2. Phaneritic or coarse-grained. Phaneritic, from the Greek word phaneros, meaning visible, describes the texture of igneous rocks in which the mineral crystals are large enough to be seen easily with the naked eye. This texture forms when magma cools slowly deep beneath the Earth's surface. Because the cooling process takes a long time, the minerals have enough time to grow into large interlocking crystals. Example, granite. And based on composition. 1. Mafic magma. Mafic magma is a type of molten rock magma that is rich in magnesium, megagram, and iron. Fe, the word mafic actually comes from combining magnesium and ferric, which means iron-bearing. It typically forms from the partial melting of rocks in the Earth's mantle, and is responsible for creating many of the dark-colored volcanic rocks you see, especially on the ocean floor. 2. Felsic magma is a type of molten rock magma that is rich in silica COs and light-colored elements like feldspar and silica minerals quartz. That's actually where the term felsic comes from. Fel for feldspar and sic for silica. This magma usually forms in the continental crust, where rocks melt under high temperature and pressure conditions. There are two types of igneous rocks based on where they form. 1. Intrusive igneous rocks. Intrusive igneous rocks, also called plutonic rocks, are types of igneous rocks that form when magma cools and solidifies slowly beneath the Earth's surface, because they cool slowly underground. These rocks have enough time for large crystals to grow, making the minerals visible to the naked eye. Example, granite. 2. Extrusive igneous rocks. Extrusive igneous rocks, also called volcanic rocks, are types of igneous rocks that form when magma reaches the Earth's surface as lava and cools quickly. Because they cool rapidly, there isn't much time for crystals to grow, resulting in rocks with small, barely visible crystals or even a glassy texture. Sedimentary rocks. Next, we have sedimentary rocks. Sedimentary rocks are types of rocks that form through a process called lithification. Loose sediments are turned into solid rock through compaction and cementation. These sediments often come from weathered rocks, transported by wind or water, and deposited in layers. Over time, these layers build up, and the weight causes compaction. Minerals in water act as glue, cementing the particles together. Sedimentary rocks are categorized into three types. Clastic sedimentary rocks. Rocks are a type of sedimentary rock formed from fragments or clasts of other pre-existing rocks. Example, sandstone. Chemical sedimentary rocks are types of sedimentary rocks that form when minerals dissolved in water come out of solution, precipitate and harden into solid rock. Example, rock salt. Organic sedimentary rocks are types of sedimentary rocks that form from the accumulated remains of living things, such as plants, animals, shells, and other organic materials. Common examples of sedimentary rocks include conglomerate, sandstone, shale, and limestone. Metamorphic rocks. The word metamorphic comes from meta, meaning change, and morph, meaning form. These rocks begin as either igneous or sedimentary, but they change due to heat and pressure without melting. This process is called metamorphism. Involving physical and chemical changes in a rock under extreme conditions, rocks are classified into two types. 1. Non-foliated metamorphic rocks are metamorphic rocks that do not have layers, bands, or aligned mineral grains. Their mineral grains are arranged randomly or grow in blocky, massive crystals without a preferred orientation. Examples, marble, quartzite. Foliated metamorphic rocks are metamorphic rocks that show distinct layers, bands, or stripes of minerals. This banding happens because of intense pressure applied in one direction, causing the minerals to realign and flatten into parallel layers or bands. Examples, slate, serpentine. Types of metamorphism include contact metamorphism, also known as thermal metamorphism, is a type of metamorphism that happens when rocks are heated by nearby magma or lava, but without significant pressure, creating non-foliated rocks. Regional metamorphism. Regional metamorphism is a type of metamorphism that happens when rocks are exposed to intense heat and very high pressure over large areas, usually deep beneath mountain ranges or where tectonic plates collide, forming foliated rocks. The rock cycle. Now, let's tie it all together with the rock cycle, a continuous process that describes how rocks change from one type to another over time. Igneous rocks can break down into sediments, which become sedimentary rocks. These, in turn, can be buried and transformed into metamorphic rocks. And any type of rock can melt into magma again, restarting the cycle. It's a never-ending process that shapes our planet. Rocks and minerals may seem ordinary, but they hold the story of our planet's history. They form mountains, create soil, and help support life. Let's take care of our environment by understanding and respecting the materials that make up our planet. Thank you for joining me today. See you in our next lesson. Alright, everyone. I hope you enjoyed our video presentation about the different types of rocks: igneous, sedimentary, and metamorphic. Now it's time to put what you've learned into practice. We'll have a quick and simple activity where you'll look at pictures and descriptions of different rocks and classify each based on how it was formed. Instructions: get your 1/4 sheet of paper and number it 1 to 5. I'll show you pictures and read each rock's description. After each, decide if it's igneous, sedimentary, or metamorphic. Write your answer next to the number. Ready? Let's begin. Rock 1. This rock forms from the slow cooling of magma beneath the Earth's surface. It has large, visible crystals. Write your answer for number 1. Rock 2. This rock is made up of tiny sand grains cemented together over time, often in water-rich environments like rivers and deserts. Write your answer for number 2. Rock 3. This rock was once limestone but changed due to intense heat and pressure beneath the Earth's surface. Write your answer for number 3. Rock 4. This rock forms from the rapid cooling of lava at or near the Earth's surface. It is dense and dark-colored. Write your answer for number 4. Rock 5. Formed from compacted mud and clay particles. This rock easily breaks into thin flat pieces. Write your answer for number 5. And we're done. Great work, everyone. When you're finished, take a clear picture of your answer sheet and send it through Messenger or comment your answers down below if you're joining online. We'll check your answers together later and see how well you understood the rock cycle and rock classifications. Thank you for participating.